All right, I'm not quite sure what happened there, but let's try this again. All right, we have two quadrilaterals here. Here's our original, and here's our image, and it wants to know two things. First, it wants to know the scale factor of the dilation. It also wants us to know if it's an enlargement or a reduction. Well, first of all, we can tell what this is, right? Pretty easy to tell that this got larger. So we're going to call that an enlargement here. However, we do need to find the scale factor. So in order to find the scale factor, what we're going to do is we're going to compare some of the coordinates to the others. We're going to write ratios of the x-coordinates from the original to the image. So let's look at point V, only because point V is very, very nice on a dot here. I have to go back 2 and up 2 to get to V. So the values of V are 2, negative 2, I'm sorry, negative 2, 2. The values of V prime, or its image, are 1, 2, 3, 4, 5, negative 5, and up 1, 2, 3, 4, 5, up 5. The x value and the y value. So in order to solve these, what we have to do is write a ratio. So let's compare the x-coordinates. These are the x-coordinates here. And I'm going to compare them from the image, because the image is where I last was, to the original. The image was negative 5 over negative 2. I know that the negatives and the negatives will make a positive, so I know that this is going to be 5 over 2, which I know is the same as 2 and a half. And it got larger, so this image was 2 and a half times larger. What would have happened if I chose to pick the y values instead of the x values? Well, I still would have had 5 over 5, the image to the original. Oh, sorry, not 5 over 5, 5 over 2. Let's see if the eraser will work quick enough for us, okay? 5 over 2, which then is going to give us the same value as what's over here, 2 and 1/2. Yeah, but Miss Bednar, what if I didn't pick letter V? What if I picked a different letter? Well, you're going to get the same. Let's try W. It's not quite as easy, but the original W was over 2 up 1, and the image of W was over 2, 3, 4, over 5, up 2 and a half, we're assuming. So that's what makes this tough, is that we have to assume that's what happened. Let's take the images and compare them. I'm going to take the image of W and compare it to W. So I'll have 5 over 2. Well, wait, that's the same ratio as the other ones. All right, good deal. Let's try this one. 2.5 over 1. Oh, Miss Bednar, now we have a problem. That's not the same. But is it? Take a minute to look. 2.5, isn't that the same as this? So all of these are the same. So this is fairly easy to assume that the enlargement scale factor is 2.5. Let's try one more before we go. First of all, we need to know if it's an enlargement or a reduction. Remember, the not with the little marks here, was the original. So this blue triangle was the original. The green is the new image. Probably a reduction, but let's find out. All right, let's go with letter A, only because letter A is nice and on the dots. So I know that A here was back 3, 1, 2, 3, and down 1, 2, 3. So it's negative 3, 3 for the point of A. And the image of A was back 2, down 2. Back 2, down 2. I missed a negative sign up there, excuse me. All right, so let's start writing our ratios. Make sure you start with the image. So negative 2 over negative 3. And both of these are going to be the same no matter if I do the x-coordinate or the y-coordinate, so we'll just leave it like that. Negative over negative is a positive. Well, wait a second, Miss Bednar. Doesn't that mean that this should have been an enlargement? Nope. Ignore the negative signs. They don't matter. Here what matters is the fact that this is a fraction that is less than 1. The fact that it is less than 1 tells me that this whole thing was going to decrease. It got smaller. Now here, the tough part here is just knowing what the scale factor is from the points that were on there. This C does not land at 2.5. So even if I tried to use C as a value, I'm not going to get there because it's going to be a different point. So if we have an actual point to pick, try that. All right, last but not least here, here's X. That's my center. Everything I do is going to work around here. I want to create the new image from this triangle. It's a scale factor of 7 over 3. 3 goes into 7 twice with 1/3 left over. I chose to write it this way just to see if I could figure out if it was going to be an enlargement or a reduction. And the fact that this is 2 times as big tells me it's going to be larger. It's going to get bigger. If I look at point X, assuming this is 0, 0, we have 1, 5. So X would be 1, 5. Then all I have to do to find the images is take those and multiply them. Take the X value times 7/3, and I would get 7/3. And take your Y value. And now Miss Bedner's making a big mistake here because X is our center, so we don't have to do X at all. We have to do the other two because X is going to stay where it is. So let's go to Y. 6, 3. See, I'll never admit it again, but even your teachers make mistakes. So 6 times 7/3, you'll have to trust me on this, is going to be 21. And the other point is 3 times 7/3, and you'll have to trust me on this. The answer is going to be 7. So we'll have 21, 7 as the new point for Y, because that's what we were finding was Y. So the image of Y is there. And then do the same thing for Z. If Z is 1, 2, again, you're going to take 1 times 7/3, and you'll get 7/3, and you will take 2 times 7/3, and you will get 14/3, which you convert, so we're going to have 4 and 2/3. So our new points are 2 1/3 and 4 2/3. All right, feel free to try some more of those on your own. Here's another example you can try in class together. Go ahead and hit pause at this time. Welcome back. Here is your summary. Write out what you think your summary should be, and good luck on your homework.